Hello. So this video is about how to do a one-way ANOVA using Excel. So an ANOVA isn't part of the Excel's normal functions. So the first thing we've got to do before we can do a one-way ANOVA, or indeed any more complicated statistics, is to have an add-in for an additional data pack. So to do that, we're going to pop up to File, down to Options, and then within Options we're going to click Add-ins, and the one that we want is Analysis Tool Pack. I'm going to click that, and I'm going to go, yes please, I would like one of those. So this pops up in your Data tab, and you can see that tool pack has now appeared just here, and that will allow us to do an ANOVA. So I have got some data for our ANOVA. So I've got 8 different conditions, a load of data to analyse. I've worked out averages for each of my conditions as well as deviations, and I've plotted these in a bar chart. It's really important to look at your data and think about your data as you go along, so you have an idea about what it looks like, rather than just relying on numbers. And then if you see any errors either in your statistics where you don't think something sits quite right, or in the averages or the standard deviations, from looking at the data, it's much easier to spot them if you plot them on a graph than it is if you're just looking at the numbers. So this is my graph, and I think it's relatively clear that there might be some differences within this data set, because there's this condition 6 up here that's popped right up, and it's much higher than the others, but obviously it does have quite a big standard deviation on it. There's a lot of error within that sample. Sorry, error is probably not the best word. There's a lot of variation within that sample, so the error bars are quite big. So what we need to do is we need to do an ANOVA to determine if there is any differences within this data. Okay, so the reason that we're using an ANOVA rather than doing several different t-tests is because we aren't looking at these individual conditions, comparing them to each other in isolation. This is a whole data set, so we need to compare and look at that whole data set statistically in one go, and that's why we're doing an ANOVA. So to do the ANOVA, rather than making a formulae like we do with a t-test or a mean or a standard deviation or whatever, by pressing equals and then typing it in the functions bar, we have to go through this data analysis tool pack. So we're going to click here on your data analysis tool pack, and there's quite a few things you can do in here, but we want a one-way ANOVA, so an ANOVA with a single factor. So ANOVA single factor, I'm going to click OK. So it's guessed the data range that I want to input here, which isn't far off actually, so I'm just going to move that down one by pulling it over. I've included the labels for my data, and I can tell it that I've done that. So there's a little tick here, labels in the first column. Yes, they are. Is my data grouped in columns or rows? And it knows that it's grouped it in rows. So that's my first condition, that's my second condition, that's my third condition, and so on and so forth, and they are in rows. The alpha, this is basically the p-value. So we're saying that a p-value of 0.05 or less is what we're deeming to be significant. And it's saying what the output range is. So where do we want, when it's calculated the ANOVA, where do we want that information to go? So I would like it to go just here. So I'm going to click on that cell just here. You can get it to put it in a new worksheet, but I think it's easier to have it all on one page so you can see what's going on. So I've got my data range, which is just here. It's grouped by rows. My labels are in the first column. My p-value is 0.05, and I've told it that I want the output, so the statistical test basically, to pop up down here. Then I just click OK, and then it just drops it in here. So the first thing it does is it tells me what it's done. So a single factor, a one-way ANOVA. It gives me a quick summary of some stuff that we already know. So it tells us about the conditions that we've got, the number of pieces of information in each condition. It tells me about the sum, the average, and we'd already determined those to do our graph, but they're there anyway, and then the variance. So then this is the bit that we're interested in, so the ANOVA. So the critical bit here is the p-value. So here the p-value is denoted as a function of 10, and that's what the E stands for, to the minus 10. So basically this p-value is so small that it's 0 point and then 10 zeros after it and then 0.2. So that's a very small p-value, and so you would obviously not pop that into report. You might write something like p is less than 0.00000001, for example, or just something that makes that number a little bit more manageable. If you did want to go on to find out where within the ANOVA which of your conditions are different between each other, you can do further statistical tests where you then look at where the ANOVA is then looked at, the variance within the ANOVA is looked at, and those are then determined, but that isn't a function of Excel. The best thing that you can do is just do a series of t-tests, so this to this, and then this to this, and this to this, and so on and so forth. And obviously that will take you quite a while because you've got 8 samples, but obviously you can copy and paste your formulae from place to place. That should speed it up a bit. The problem with that is that you aren't incorporating the overall variance of your experiment. You're just looking at single conditions combined, and that basically reduces the sensitivity of your statistics. However, if you want to find out where within your dataset those differences are, and you can only use Excel, that's probably the best way that you've got to do it, is to then go on and do some t-tests, and obviously just be very clear that that's what you have done in your report. And again, I hope that has been helpful. Thank you very much.